So we're going to solve this problem using a for every statement. So a for every statement is, here it says, write a for every statement for the relationship between aluminum and copper. So I look here and there's 2 aluminum and there's 3 copper. So my for every statement is going to be for every 2 moles of aluminum, there are 3 moles of copper. So that's my for every statement. Now I'm going to use that for every statement to solve the next problem. It says predict how much aluminum will be formed when 12 moles of copper react. So I'm going to recopy here my for every statement. All right, so that's my for every statement. This always comes from the balanced equation. And so now I'm going to take the new information that I'm given, and the new information I'm given is that there are 12 moles of copper. So I'm going to line up 12 moles of copper right below the 3 moles of copper, the moles of copper. To go from 3 to 12, I'm going to multiply by 4. So this same process has to happen here. So 4 times 2, so I'm going to get 8 moles of aluminum. So my answer is going to be 8 moles of aluminum. Is how I'm going to answer this problem. Let's try another one. If I now write the for every statement, so I'll do my for every statement again in red. Doesn't really matter, but here, my for every statement comes from the balanced equation. And so it tells me, balanced equation up here, there are 2 moles of AlNO3, aluminum nitrate. And so for every 2 moles of that, there are, for the copper, 3 moles of copper 2 nitrate, CuNO3 2. So there's my for every statement. So now I'm going to solve it. I'm going to use my for every statement here. So I'm going to recopy it. 2 moles of AlNO3 3. There are 3 moles CuNO3 2. Now I'm going to look at my given, and in this problem it says there are 7.2 moles of Al2O3. So 7.2 moles of NO3, 3. Okay, so to get from here, to get from 2 to 7.2, I'm going to have to multiply by 3.6. So over here, I'm also going to have to multiply by 3.6. So 3.6 times that 3 is going to give me 10.8 moles of CuNO3 2. So there's my answer to that next one. Last one on the page. Start with my for every statement. My for every statement always comes from the balanced equation. And here there are, for every 2 moles of Al, there are 3 moles CuNO3 2. So now I'm going to recopy my for every statement. Big idea, for every statement always comes from the balanced equation. Think of it like the recipe. This is what it always has to be. It doesn't change based on what I have in my cabinet, so it doesn't change based on the problem. So now I'm going to look at my problem, and it says 0.137 moles of Al are formed. So 0.137 moles Al. Notice I line that up below Al. And then now what am I going to do? I have to see, to go from 2, to go from 2 to 0.7, okay, what do? I try to multiply by 0.0685. So how did I figure that out? Okay, I said what number times 2 will give me 0.137, and so basically I took the 0.137, I divided by 2, and that's where I got my 0.0685. So over here, I have to multiply by 0.0685 times 3, and I get 0.2055 moles of CuNO3 2. And so right there is going to be my answer for the last one. So that's how you go about solving these mole-to-mole problems using for every statements.